Okay, now we're going to go through paper 1, which is the multiple choice core option for chemistry. This is from IGCSE, from Cambridge International Examination, CIE, from May-June 2018, and the code is 0620/11. All right, let's begin.
You ready? Ready.
Question 1. The diagrams show particles in a container. Okay, which diagrams show the process of evaporation? Okay, container 1, it has about half of the molecules touching approximately, and it flows into the shape of the container, so this would be a liquid. Okay, container 2, well, all the particles are touching, and it goes into a particular shape that's not the shape of the container, so that would be a solid. And 3, the particles aren't anywhere near touching, so this would be a gas. So which diagram shows the process of evaporation? In evaporation, you go from a liquid to a gas. So that's 1 to 3. The answer is B. Question 2. Which piece of apparatus is used to measure exactly 26.3 centimeters cubed of a liquid? If you want to be exact, you need to use a burette. And this one is a burette. Okay, so it would be A. This one is a gas syringe. This one is a pipette. If you notice, there's no gradations on here, so you can't see exactly how much it is. And there are ways you can make it so it's very specific, but 26.3 is a large value for using a pipette to measure exactly. And this one is a measuring cylinder or a graduated cylinder. And if you notice, the diameter of this is much wider than the diameter of this, which means that the measuring cylinder is going to be less accurate. It's faster, but it's less accurate. Okay. Question 3. The melting points and boiling points of pure substances W, X, and Y are shown. Okay, the substances chlorine, ethanol, and sulfur. So those are what they are. Which row identifies W, X, and Y? Okay, so the melting point of W is well below 0, minus 114. But the boiling point is well above 0, 78. So that means at room temperature and pressure, or 21, 24 degrees, it will be a liquid. Okay, so this one is going to be ethanol because it's a liquid. It melts really early, really low, and it boils lower than water, but it boils higher than room temperature. So it's going to be a liquid at room temperature. Okay, X, it melts at a really high temperature and it boils at an even higher temperature. So this one is going to be a solid until you get to 115 degrees Celsius. So that one will be sulfur because the melting point and boiling point are very, very high. And Y, it boils at minus 34 degrees Celsius. It's almost at room temperature pressure. It's going to be a gas. So that looks like chlorine. So any of these options, W would be ethanol. That looks like the answer is B. I'm going to circle it, but let's just double check. X is sulfur. That's correct. Chlorine is Y. That looks like the answer. There we go. The answer is B. Question 4. In which atom is the number of protons equal to the number of neutrons? Okay, so let's look at these. So we have protons and neutrons in each one of these. We just write down how many there are. Okay, in argon, the mass number is 40. So in argon, the mass number is 40, and the proton number is 18. So 18 is the proton number. The mass number is 40, so that the neutrons are 40 minus 18, and that equals 27. So 27 does not equal 18. It's not argon. Okay, in fluorine, the mass number is 19. So the mass number is 19, and the proton number is 9. So that means 19 minus 9 means the number of neutrons is 10. So we have protons, that's 9, and neutrons is 10. Those don't equal either, so it's not that one. Sodium, the mass number is 23. So 23, and the proton number is 11. So 23 minus 11, that's 12. So the number of neutrons is 12. So we have 11 protons and 12 neutrons. That, again, it doesn't equal each other. and oxygen, 16 is a mass number. So 16 is the mass number, and oxygen has 8 as a proton number. 16 minus 8 is 8. Looks like the protons equals the neutrons. So 8 protons, 8 neutrons. The answer is D. There we go. Question 5. Which row identifies an alloy, a pure metal, and a non-metal? Okay, so an alloy, is that brass or is it copper? Well, copper is one particular type of metal, and brass is a combination of copper and zinc, so it's an alloy. Okay, a pure metal, is carbon a metal or is copper a metal? Well, copper is a metal, and a non-metal, carbon is a non-metal. And remember, here's the periodic table, and this line here, so zigzaggy line, separates, we have metals on this side, and we have non-metals on this side. So carbon is a non-metal and copper is a metal. So the answer is B. Question 6. A covalent molecule Q contains exactly 6 shared electrons. What is Q? Is it ammonia? Well, ammonia has an N in the middle, NH3, H. The H is all evenly separated, so dot and cross diagram. One dot will be from one of the sets of atoms. It could either be 3 from the nitrogen or 1 from hydrogen, 1 from hydrogen, 1 from hydrogen. And we have a cross, 3 from nitrogen, and again 1 from hydrogen, 1 from hydrogen, 1 from hydrogen. So it will be ammonia because this is 1, 2, 3, 4, 5, 6. Okay, but just looking at the other ones, we have Cl2, Cl, Cl. Now, they all have to have full valence electrons. So full valence shells. So we put X's around this one, dots around this one, and we'll have 1 dot and 1 X, and these ones will be shared. And looking at the periodic table, chlorine is in group 7. It's missing 1 electron from its outer shell, so that makes sense. So it's not chlorine. Carbon, methane, CH4. Okay, methane, let's do it here. We have C. Carbon has 4 electrons in its outer shell. And then we have hydrogen, 4 hydrogens. Each one of those, we'll do a dot for each one of those. And if you look at that, it's 1, 2, 3, 4, 5, 6, 7, 8 shared electrons. That's not methane either. And water. We have oxygen has, we have H and H. Okay, so we have 1 hydrogen, 1 electron from hydrogen. We have 2, 4, 5, 6 from oxygen. And in total, that makes up 8. All right, because hydrogen's only missing 1. And oxygen is in group 6. So it's missing 2. There we go. So the answer is ammonia. Question 7. The lead in a pencil is made from a mixture of clay and graphite. Graphite and clay. It's no longer made from lead. It used to be, but it's not anymore. When the percentage of graphite is increased, the pencil slides across the paper more easily. Which statement explains this observation? So, graphite has a high melting point. Well, yes, but that has nothing to do with sliding across a paper. So, graphite is a form of carbon. Yes, but sliding across a paper does not explain that it's carbon. It could be something else sliding across the paper. Graphite is a lubricant. Yes, lubricants make things slide more easily past each other. So the answer is probably C, and graphite is a non-metal. Yes, but sliding across the paper more easily does not actually show that it's a non-metal. There's lots of non-metals and lots of things that slide across the paper more easily that are metals. Question 8. The equation for the reaction between magnesium and dilute sulfuric acid is shown, and the molecular mass of MgSO4, magnesium sulfate, is 120 grams per mole. Which mass of magnesium sulfate is formed when 12 grams of magnesium completely reacts with dilute sulfuric acid? Okay, so the first thing, 12 grams. Okay, is 12 grams a useful number to us? No, you don't look at grams when you're looking at the equations. You need to know moles. 1 mole of magnesium reacts with 1 mole of sulfuric acid, dilute sulfuric acid, producing 1 mole of magnesium sulfate plus 1 mole of hydrogen. Okay, because there's no number in front of the reactant or product. Okay, the molecule. So, change this into moles. Moles equals mass over the relative molecular mass. Okay, that equals 12 grams, as it says, of magnesium. All right, so now we look up what magnesium is. So magnesium has a molecular mass of 24. So it's 12 grams divided by 24 grams per mole. And then, so that means the answer here is 0.5 moles of magnesium. Okay, so 0.5 moles of magnesium plus 0.5 moles of sulfuric acid produces 0.5 moles of magnesium sulfate plus 0.5 moles of hydrogen, just because it's a 1 to 1 to 1 to 1 ratio. Okay, so now we need to figure out, it says which mass of magnesium sulfate. Now we need to figure out, we know it's 0.5 moles, we need to convert that back into mass. Okay, so if moles equals mass over relative molecular mass, then mass equals moles times relative molecular mass. Okay, so the moles, we know that's 0.5 moles times 120 grams per mole. And the answer there is 60 grams. When you plug that into the calculator, you get 60 grams. So look, that is answer C. There we go. That's it. Question 9. What is observed at each electrode when molten lead-2 bromide is electrolyzed using platinum electrodes? Platinum electrodes, the key thing with platinum is it's unreactive. So using unreactive electrodes. All right. So let's draw our little electrolysis cell. All right, so we have two electrodes. Obviously, this is on a tilted table because the solution is at an angle. That's okay, whatever. All right, so we have one negative and one positive. And it doesn't really matter which one's a cathode and which one's the anode here. They're connected so that it's a circuit. And we have molten lead-2 bromide, which means there's only the lead-2 bromide in there. So we have lead, Pb2+, because it says lead-2, and bromide, Br-. Okay? It doesn't even matter if you remember which one, if it's 2+ or 1+ or minus for this, because it's looking at what's formed. Okay, you do need to know which one is positive and which one is negative. Okay, so you have Pb2+, Br-, floating, a lot of those floating around in the, not solution, in the molten lead-2 bromide. And the plus will go to the minus. And the minus will go to the plus. All right. Now, so this electrode, you're going to have lead forming on the outside or falling down, forming underneath. Okay, so lead is it a colorless, so that's a negative electrode. Is it a colorless gas? No, lead is a metal. So it is a shiny gray liquid? Yes, and the reason why it's a liquid is because it's molten. All right, so a shiny gray liquid will be right by the negative electrode. And the Br-, bromine, is a colorless gas. If it's molten lead-2 bromide, it will be a gas. That's not colorless gas. Sorry, I said a colorless gas. It's not colorless at all. It is brown, because bromine is a yellowy brown color. So the answer is C, because this will be bromine at the positive electrode. Question 10. Which gas is used as a fuel? Is it argon, hydrogen, nitrogen, or oxygen? Well, argon is unreactive. It's in group 8. It's a noble gas. It's not going to be used as a fuel. Nitrogen, again, not very reactive. N2 is very difficult to react except if in certain situations. Is it hydrogen or oxygen then? Well, both of those burn, but oxygen is needed for burning. So it's a reactant. But it's not the fuel. Hydrogen is then possible to be used as a fuel. And that's where you get hydrogen fuel cells, made from splitting water into hydrogen and oxygen. And they're quite clean cells to use as batteries. Question 11. Burning fuels is an exothermic reaction. What is meant by the term exothermic? Exo meaning outside. Thermic meaning heat. So you feel the heat outside. So a gas is produced. That has nothing to do with outside heat. Energy is released. Yes, that makes sense because energy is released. When energy is increased, that increases the temperature of something. So if it's released, it will increase the temperature of the surroundings. Heat is absorbed. No, if heat is absorbed, the surroundings will get colder, and the actual reaction will have more energy, but the thermometer reading the reaction will get colder. We'll show that it's colder. And the mass of the fuel decreases. Mass has nothing to do with outside heat. So the answer is B. Question 12. The diagram shows a rate of reaction experiment. Okay, so we have magnesium reacting in acid. And if you remember, magnesium, or metal plus acid, magnesium plus acid produces a salt plus hydrogen. And hydrogen is being collected in this gas syringe. And as the reaction progresses, the plunger will be moving farther out that way as the volume of gas has increased. So increasing the concentration of acid and increasing the temperature both affect the rate of reaction. Which row is correct? So if you increase the concentration of acid, you will have more acid molecules there to react. So that means the reaction will go faster because there's just more things there to react, more chances of things bumping into each other. If you increase the temperature of reaction, when they bump into each other, first of all, they'll be moving faster, so they're more likely to bump into each other. And when they bump into each other, they'll have more energy, so they're more likely to create a reaction because they have to get past their activation energy. So the answer is D. Question 13. Water is added to anhydrous copper 2 sulfate. Anhydrous means no water. So that's dry copper 2 sulfate. What happens during the reaction? Okay, so dry copper 2 sulfate starts off blue. So it's one of these two. And does the solution get warmer or cooler? Okay, this reaction, it gets warmer. Okay, so the answer is B. And the reason why is because it's a reaction with the salt reacting with the water, and that is an exothermic reaction. Question 14. Which equation shows an oxidation reaction? It doesn't say a redox reaction. If it says redox reaction, it would definitely be needing a salt, and it would need to show oxidation and reduction very clearly. An oxidation reaction, generally, what they're talking about is gain of oxygen. Okay, that's what they're talking about. So calcium carbonate is actually losing some oxygen from the reactant, so it's not that one. Calcium oxide, again, the calcium is losing oxygen, so it's not that one. The N2O4 is breaking up into two different reactants, two different products. So it's the N is losing oxygen, but here carbon is gaining oxygen. So the answer is A. Question 15. Dilute nitric acid is added to a solid F. Okay, a gas G is produced which is denser than air and extinguishes a burning splint. Okay, that to me sounds like carbon dioxide. Okay, because carbon dioxide is heavier than air, so it will settle if you have it in a conical flask. carbon dioxide will stay at the bottom and the normal air will be above. Okay, and the burning splint, well, you need oxygen to light a splint, so that's the test. That is the test for carbon dioxide. Does it extinguish a burning splint? So what are F and G? So dilute nitric acid is added to a solid F, and G is a gas. We've already said, so gas, it's not going to be hydrogen because that's a squeaky pop test. So it will be carbon dioxide. Now, if it's producing carbon dioxide, it needs to have something like a carbonate, because remember, an acid plus a carbonate produces a salt plus carbon dioxide. Okay, so the answer is B. It's a carbonate. It's not just plain calcium. You need to get the carbon dioxide from somewhere. Calcium hydroxide, again, you need to get the carbon from carbon dioxide somewhere. And calcium oxide, same thing. You need to get the carbon from somewhere. Nitric acid has no carbon in. Question 16. Which statement about oxides is correct? So a solution of magnesium oxide has a pH less than pH 7. Well, magnesium oxide, that is a basic oxide, which means it has a pH greater than pH 7. So that is a no. Solution of sulfur dioxide has a pH greater than pH 7. Sulfur dioxide produces sulfuric acid when it reacts with water. So that'll be a pH of less than pH 7. It's acidic. Magnesium oxide reacts with nitric acid to make a salt. Well, if magnesium oxide is a basic oxide, that would be an alkali. It's a K. An alkali plus an acid of nitric acid produces a salt plus water. So that looks like it's the answer. And sulfur dioxide reacts with hydrochloric acid to make a salt. An acid plus an acid makes a salt? No, that's not any of the reactions that you were ever taught, I'm sure, because it's not true. Question 17. Which methods are suitable for preparing both zinc sulfate and copper 2 sulfate? Okay, so if you react the metal oxide, so zinc oxide with dilute aqueous sulfuric acid, so zinc oxide plus dilute aqueous sulfuric acid, or copper oxide plus dilute sulfuric acid, will you get zinc sulfate or copper 2 sulfate? Yes, you will. If you react zinc, the metal, with dilute aqueous sulfuric acid, will you get zinc sulfate? Yes. If you react copper with dilute aqueous sulfuric acid, will you get copper 2 sulfate? You won't actually, because it's dilute aqueous sulfuric acid, and copper is quite unreactive. It won't react really very easily at all. It has to be more concentrated or warmed, so it really won't react. And if you react the metal carbonate, so zinc carbonate or copper 2 carbonate or copper carbonate with the dilute aqueous sulfuric acid, will it create the salt? Yes, it will. So the answer is 1 and 3 only. So C. Question 18. 2 salt solutions, X and Y, are tested. The table shows the results. Okay, so the tests, we have a few drops of aqueous sodium hydroxide are added, and then a green precipitate is formed, or red precipitate is formed. Well, a green precipitate formed, that shows iron 2. And a red-brown precipitate, that shows iron 3. Okay, so that works. Okay, so a few drops of dilute nitric acid and a few drops of barium nitrate are added. Okay, so this is a test for the sulfate ion. Okay, SO4 2-. So if a white precipitate forms, that means it's a sulfate. Okay, and a few drops of dilute nitric acid, then a few drops of silver nitrate. This is a test for chloride. Okay, so Cl-. So if a white precipitate is formed, that says Cl-. Okay, so chloride ions. Okay, so what is X? X, we said was iron 2, so it's either iron 2, chloride, or iron 2 sulfate, and we said it was a chloride. So the answer was probably A. Let's double check. Y, we said it was iron 3, so that makes sense. And sulfate, yes, it says sulfate. So that's 2 checks there. So the answer is A. Question 19. Which element is in the same period? Okay, so a period, remember the groups go down and the periods go across. Okay, which element is in the same period of the periodic table as silicon? So let's look at them. We have germanium, scandium, sodium, or strontium. Okay, so we have, as I said, we have germanium, we have scandium, we have sodium, and we have strontium. And we are looking for the one that's in the same period as silicon. That's the one that goes along this way. So the answer is sodium. There we go. So the answer is C, sodium. Question 20. Which statement about the halogens is correct? The halogens being group 7. Chlorine, bromine, iodine, those are the group 7 ones. Okay, so remember, so this is about which ones react with which. So remember, chlorine, Cl2, is more reactive than bromine, Br2, which is more reactive than iodine, I2. So chlorine, bromine, iodine. Chlorine, this is the most reactive. Well, fluorine is most reactive, and astatine is the least reactive. Okay. So when it says that bromine reacts with potassium chloride solution, that would mean that bromine would have to be more reactive than the chloride, because the one that's the most reactive is the one that will end up in the salt. Basically, it would kick the other one out, so it will be paired up with the other half of the salt. Okay, the one that's stronger will end up in this as a salt. So is bromine more reactive than chloride? Nope. So that it says, so chlorine is more reactive than bromine. Is bromine, a sample of bromine reacts with potassium iodide. So bromine is more reactive than iodine. Well, yes, that looks right. Okay, I'm going to say B, but let's double check the answers. A sample of chlorine has a higher density than a sample of bromine. Well, chlorine is a gas and bromine is a liquid, easily turning to a gas at room temperature, but chlorine has a lower density because it's always a gas at room temperature and pressure. So it's not that. And a sample of chlorine is a darker color than a sample of bromine. Nope. Bromine is a yellow-brown color, which is darker than chlorine. So the answer is B. Question 21. Which row shows the catalytic activity of transition elements and their compounds? So, transition elements, do they make good catalysts? Yes. Yes, they do. Do transition elements make good catalysts if they are combined as a compound? Well, yes, they still make good catalysts even if they're compounds of the transition elements. So we want something that's a good conductor as a normal element, it's just a plain element, and a good conductor if it's combined as a compound. They're just good, not conductor, they're just good catalysts. There we go. Question 22. Which statement about noble gases is not correct? Always double check when it says not, that you read this carefully. Okay, so A. Noble gases are diatomic molecules. Nope, noble gases are just single. So we have argon is just plain argon. We have helium, just plain helium. Okay, I'm not going to go through them all, but they're not diatomic means Cl2. That's a diatomic molecule. Okay, noble gases are unreactive gases. Yep, that is correct. Noble gases have full outer electron shells. That is correct. And the noble gas argon is used in lamps. That is also correct. So the answer is A. Question 23. The following statements are made about the metals copper, iron, magnesium, and zinc. So their oxides are acidic. Well, no. Pretty much most of their oxides are actually basic. Magnesium oxide, zinc oxide. So it's definitely not that their oxides are acidic. They all conduct electricity in the solid state. Well, yes, they're metals, and that's one of the characteristics of metals. When they're solid, they conduct electricity because they have their sea of electrons. They all have high melting points. Yes, they do. Mercury doesn't really, but most of the other metals do. They all react with dilute acids to form hydrogen. Yeah, not dilute acids. They will react with acids, maybe strong heated up acids. Copper is not very reactive at all and will not react with dilute acids to form hydrogen. So no, the answer is 2 and 3 only. Question 24. 3 metals, X, Y, and Z, were reacted with water. The oxides of the same 3 metals were also heated strongly with carbon. The results are shown. So these are the results. If you react metal X with cold water, it has a vigorous reaction with cold water. If the metal oxide is reacted with carbon, there's no reaction. If Y, there's no reaction with the metal with water, and the metal and carbon dioxide are produced if it reacts with the oxide reacts with carbon. And Z, there's no reaction observed with cold water, but there's a reaction observed with steam. And when you react the metal oxide with carbon, there's no reaction again. So what could the result be? Okay, so if we look at these possibilities down here, so X is sodium and Y is magnesium. X is sodium, vigorous reaction with cold water. Well, that sounds pretty good. Y is magnesium. There's no reaction of metal oxide with carbon. Well, there actually is a reaction. It reacts with carbon to form magnesium and carbon monoxide. Okay, so that isn't true. So X is the least reactive and Y is the most reactive. Well, if it was the least reaction, there wouldn't be any reaction with water, let alone cold water. So that doesn't make sense. All right, and Z is less reactive than Y. Z, so no reaction observed with cold water, but there is a reaction observed with steam. But if we look at this, at Y, there's no reaction with water at all. Makes me think that no, it's not answer C. And Z is magnesium and Y is copper. So magnesium, no reaction observed with cold water, but there is a reaction observed with steam. That sounds like magnesium. Y is copper, metal oxide reacting with carbon, no reaction. Copper is very unreactive, so the answer is D. Question 25. In a blast furnace, iron ore is mixed with coke and limestone. Remember, coke being carbon and limestone being calcium carbonate, and heated in hot air. Compound R is formed. Compound R then reduces the iron ore to iron. Okay, which equation shows the formation of compound R? So we have coke, and coke is carbon. Well, that looks like it's either A or B. Okay, so one of these two. Now, with limestone, well, none of these are calcium carbonate. C is calcium carbonate, but there's no coke. Okay, so it's not likely to be C. Now, how do you know which one's which? So when limestone, CaCO3, is heated up, it produces carbon dioxide, CO2 plus calcium oxide. Okay, which means that it looks like the answer to this is B. All right, and compound R, carbon monoxide, then reduces iron ore to iron, and that is true. So the answer is B. Question 26. Which statement explains why aluminium is used in the manufacture of aircraft? Is it because it conducts heat well? I don't see why that would be useful in an airplane. Is it because it has a low density? Well, yes, you want a plane to be light, because the lighter it is, the less fuel you use. Is it because it is a good conductor of electricity? You're not really interested in how well the airplane conducts electricity. So that's probably not useful. And is it because it is easy to recycle? You hope you're not going to be recycling your airplanes too often. So the answer is B. Question 27. Dry air is passed over hot copper until all the oxygen has reactive. So dry air made up of a lot of different things. The volume of gas at the end of the reaction is 120 centimeters cubed. So starts off with a certain amount of volume of dry air. So what is the starting volume of dry air? And at the end of the reaction, after all the oxygen has been used up, there's 120 centimeters cubed left. So what was the starting volume of air? Well, what is the percentage of oxygen in normal dry air? Because it has to be dry, because moist air can carry a wide range of water. Okay, so oxygen, O2, is 21% of dry air. Okay, so if it's 21%, that means you end up with 120 centimeters cubed, and you divide that by 79%, so 0.79. If you look at the answer, if you plug that into your calculator, that is 151.9 centimeters cubed, so 152 centimeters cubed, so the volume is B. Question 28. A steel bicycle which had been left outdoors for several months was starting to rust. What would not reduce the rate of corrosion? So remove the rust and paint the bicycle. Well, that would definitely reduce the rate of corrosion. Okay, it stops, painting the bicycle stops the oxygen and water from getting to the metal. Remove the rust and store the bicycle in a dry shed. That sounds good. You know, it's not going to be rained on, and it's not going to then react with the water and the oxygen from the rain. It's not going to be rained on, and that will definitely reduce the rate of corrosion. So remove the rust and wipe the bicycle with a clean, damp cloth. With a clean cloth sounds good, but damp? No, that's not a good way. Damp, you need the water to create rust. So remove the rust and wipe the bicycle with an oily cloth. Oil is used, it can be used to prevent the water getting to the metal, just like the paint would. So the answer is C. That's the one that would not reduce the rate of corrosion. Question 29. Which statements about water are correct? So, does household water contain dissolved salts? Yes, there's definitely salts in dissolved water, in household water. If you own a kettle and make tea or something like that, you'll probably notice that you get a lime scale around, you get a scale around the outside of the kettle if you don't clean it regularly, because that's the salts coming out of solution. Obviously, some areas will have more salts than others. So water for household use is filtered to remove soluble impurities. Now, if you read this carefully, you will notice it says filtered to remove soluble impurities. Soluble impurities cannot be removed by being filtered. Okay, if you have salt water, putting it through filter paper, you will end up with salt water at the end. Soluble means it's dissolved in the solution, so it's not going to be removed by filter paper. Water is treated with chlorine to kill bacteria. Yes, because the chlorine then evaporates off and makes the water nice and safe. Water is used in industry for cooling. Yep, that sounds good. So the answer is 1, 3, and 4 only. So C. Question 30. Farmers use fertilizers to replace minerals in the soil that have been removed by the crops they grow. Which elements in the soil are replaced by adding fertilizers? Calcium, phosphorus, and oxygen? No. Fertilizers don't add calcium or oxygen to it. Potassium, oxygen, or sulfur? Nope. Oxygen, again, you just get from the air. And sulfur, I can't see how that would be useful. Nitrogen, potassium, and phosphorus? Yes, that's the answer. You often call them NPK fertilizers because that it replaces the nitrogen, phosphorus, and potassium. They're the important ones. And nitrogen, oxygen, sulfur, again, the oxygen and sulfur are not useful. Well, oxygen you get from the air, nitrogen you get from the air, sulfur not as useful. So the answer is C. Question 31. Which statement is correct? So all of them will be wrong except one. Atmospheric carbon dioxide is not a cause of climate change. No, it is definitely a cause of climate change. Okay, it's an important cause of climate change. Atmospheric methane is produced by respiration. No, that's methane is produced by things like decay and other things like that. Burning natural gas decreases the level of carbon dioxide in the atmosphere. No, burning increases the levels of carbon dioxide. Burning a fuel increases the levels of carbon dioxide. And decomposition of vegetation causes an increase in atmospheric methane. Yes, because that is where one of the reasons you get methane into the atmosphere. Decomposition of vegetation, plants. The answer is D. Question 32. Which statement about sulfur and its compounds is not correct? Okay, so sulfur dioxide is used as a food preservative. That is absolutely true. All right, sulfur dioxide turns acidified aqueous potassium manganate 7 from purple to colorless. Yes, that is one of the tests you need to know. Sulfur forms a basic oxide. Nope, sulfur forms sulfuric acid, which is clearly acidic. Sulfur is used in the manufacture of sulfuric acid. Yes, you need sulfur to make sulfuric acid. So the answer is C. Question 33. Which process is used to convert limestone, calcium carbonate, CaCO3, into lime, CaO, plus O2? Okay. All right, so what's the process? Electrolysis? No, we use salts in electrolysis. Fractional distillation? No, fractional distillation is for separation of substances. Incomplete combustion? Well, you're not reacting with oxygen, so that's not very useful. Thermal decomposition? Basically, they heat it, and it breaks down into calcium oxide, or lime, and oxygen. So yes, it's D. Question 34. Lime is used to treat an industrial waste. Okay, so the untreated waste goes on one side. We have the lime inside this container, and then the treated waste comes out the other side after the reaction happens. Which change occurs in the treatment? So does it start off as acidic, alkaline, or neutral? Okay, what it does is lime is added to things like fields, farmers' fields, or industrial waste to neutralize an acid. So it starts off acidic and ends off neutral. You don't want it alkaline because that would then need to be treated to make it neutral. So the answer is A. Question 35. What is not the correct use of the fraction named? So fuel oil, is that used for making waxes? No, it's used for fuel. It says so in the name. Gas oil is a fuel in diesel engines? Yes. Kerosene for jet fuel? Yes. And naphtha for making chemicals? Yes. So the answer is A. So question 36. 4 organic compounds are listed. Ethane, ethanoic acid, ethanol, and ethene. Which bond do all 4 compounds contain? Okay, so let's draw it up. First of all, monkeys eat peeled bananas. 1 carbon, 2 carbons, 3 carbons, 4 carbons. Methane, ethane, propane, butane. These all are Fs. So each of these has 2 carbons. So ethane, C, C, H, 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 H. Ethanoic acid, we have C, C, H, 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 O, O, H. That's ethanoic acid. Ethanol, let's do it over here. C, C, H, 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 O, H. Okay, and then ethene is, I'll do it over here. C, double bond C, H, 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 H. So which bond do all 4 compounds contain? Well, it looks like they all have a C bond, except ethene. That doesn't have a single bond, so it's not A. Do they all have CH bonds? Yes, there's definitely CH bonds in all of them. Do they all have CO bonds? Well, not ethane. That doesn't have any CO bonds. And do they all have OH bonds? Not ethane or ethene. So the answer is B. Question 37. The first 3 members of a homologous series are shown. Why do these molecules represent a homologous series? Okay, so because they contain fluorine and carbon atoms. Nope, that's not enough. They have to be in the same proportions. Because they have saturated bonds. Nope, there's a lot of things with saturated bonds that wouldn't be in the same homologous series. Because they have the same functional groups. So homologous series always work with functional groups. So I'd say the answer is C. And because they react differently from each other, well, homologous series generally react in very similar manners. So the answer here is C. They all have the same functional groups, and that is the F, the fluorine. Question 38. Which substances can be obtained by cracking hydrocarbons? Okay, so cracking hydrocarbons requires a catalyst. So let's start with ethane as an example. So C, 4 bonds on each carbon, so 3 of these are hydrogens. Okay, if we crack the ethane, we'll have a catalyst here. This will be our catalyst, and it will basically take these 2 hydrogens and put them together to make our product, to make a product of H2. Okay, so add them together to make H2, joins them together. And when it takes those 2 hydrogens off, what it leaves behind are 2 carbons plus 2 hydrogens attached to each one of these carbons. And as each carbon needs to have 4 bonds, that means it has to be a double bond. So this is ethene plus hydrogen. So the answer is C. Question 39. Which reaction is used to make ethanol? Okay, so A, adding steam to ethene. So we start off with ethene, C, double bond C, H, 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 H. And we add steam plus H2O. Now steam, again, we have O, an H, and an H. And when you can do that, you can add it to over a double bond, because you can break one of these bonds and you'll have an OH plus an H, OH minus an H plus. So one of these gets an OH minus, and one of these gets an H plus. Okay, so if you add steam to ethene, you will get C with an OH on it, and then the 2 hydrogens are stay there. And you've broken the double bond, and you have 3 H's on the other one, and that is ethanol. So A is the answer to that. Addition polymerization, that creates a polymer. So you're not going to create ethanol from that. You're going to create a polymer. Fractional distillation of petroleum, that's a no. Fractional distillation of petroleum, that separates the different fractions of petroleum. It's for separation. And reaction of ethene with aqueous bromine. So we have C, double bond C, H, 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 plus Br2. Okay, so that will be 1 Br minus going to this one, 1 Br minus going to this one, and you will end up with C with 2 H's, C with 2 H's, because those don't leave, and a Br on one and a Br on the other. That's not going to do much good. That is not the answer either. So the answer is A. Question 40. Polymers are long chain molecules made from small molecules linked together. 4 polymers, or types of polymer, are listed. So carbohydrates, nylon, proteins, and pterylene. Which of these polymers or types of polymers are synthetic? So carbohydrates, those are things like starches. Okay, so starches are natural, they're not synthetic. Nylon, that's a man-made chemical. Proteins, nope, they're natural, they're in foods like meats and fish and things like that, and beans. And pterylene, that's another man-made molecule. Okay, so the synthetic ones are 2 and 4. The answer is D. All right, and that is the last question on this exam. I hope you found it useful and you'll do very well on your final exams. If you've liked it, I'd appreciate you press the thumbs up button. And if you haven't subscribed already, that would be very nice. We'd really appreciate that. If you have anything you'd like to say to us, please write them in the discussion section below, and have a great day.